Right, here we go. So what I wanted to do, Sayaka, was just to get a feel for where you're at, really, what your level is at with sort of manipulation of, algebraic expressions, your understanding on that. I am also as well, because we've got a bit of time, the parts that were highlighted in yellow, especially, I've thrown in a few questions in here just to see again what your general understanding on those questions are. So if you don't know how to do a question, literally just skip it. Okay, don't worry so much. It's not a test. This is really just for me to know what your level is at, so I can get a better understanding of where to pitch the lesson, if you like. Does that make sense? Yeah. So I sent you a PDF copy. So like I say, just try and whiz them as quickly as you can. It's not nothing that's meant to take up a lot of the lesson. It's just a diagnostic for my own knowledge. Does that make sense?
Yeah.
Okay, good. So you can see my board, but I've also sent this to your email, a PDF copy to your email as well. So it's up to you. So I'm here as you work through the problems. Feel free to think out loud. That's really good, because then it allows me to know how your brain is processing the problem, which is also very important for me to understand how your brain is processing, if you're going right round track, so on and so forth. Does that help?
Yeah.
Okay. Okay, good. So when you're ready, yes,
It's just, that's my cousin's dog. The first one is 0, right? Is it 0?
Not quite for the first one. Not quite for the first one. Okay.
Really? +1 and then -1, because x would be like x and y would be like cut. You know what I mean? If there's x and x.
Yeah, sort of. I sort of see.
Like so +1 and then -1.
Yeah. So this here first, just to go a little bit back to basics. So is this an equation or is this an expression? What is this? So there's a difference between an expression and an equation. Do you know what the difference is?
I don't know what an expression is.
Okay, so one thing to let you know firstly is that an equation always has an equal to sign.
Oh.
Yeah. Okay.
Okay, that's the
key thing to know. So what we have here is an expression, because this is not being made equal to anything. In other words, you do not have a left-hand side or a right-hand side. With an equation, we always have a left-hand side. So the left-hand side is obviously to the left-hand side of the equal to sign, and we have a right-hand side. So what this is asking you here is it's asking you to simplify the fraction. So if I gave you, just say if I gave you numbers, just to go back a little bit further to basics, just to make sure, like I know you told me that there were some gaps. So my job now is to firstly try and fill those gaps to make sure that you can then relate them on a high level. Okay, so imagine you were given something like this. Okay, so let's just have 3/4 and add this to say 7/11. Okay, so this is not too different from this problem. I've only used a plus and I've used numbers. How do you go about doing this if I ask you to simplify this?
So without still in an equation.
Yeah, so without using, so this is now, so solve the answer to this. What is this plus that equal to? How do you go about doing this? And again, don't worry if you're not sure. My job is to try and help you to make sure that you understand how to do it.
I would just put it into decimals, but I don't, since it says that I have to still put in a fraction.
Yeah, so if I wanted you to give me my answer in a fraction, how would you do this question? Just one moment. Let me just grab
This is
this.
really embarrassing. I don't
You're not
see
sure
it.
how to go about doing that one if you have to do it in fractions?
I really don't like fractions.
Yeah, okay, don't worry. I'm going to show you that they're not so
I would
bad.
usually just try to, if it has like a multiplication or something,
Mhm.
you know, if like, for example, there's 3 and there's 9,
Yeah,
I would usually just try to make it small, but I cannot do that here.
yeah, you can't do that
So,
here.
um,
So don't worry, I'll show you how to do it. Okay, one way to
okay.
do it first. There's a number of ways you can do it. Firstly, we know that this term here is called the denominator. You
Yeah,
know that, yeah, good, excellent. And this term here is known as the numerator. So whenever you look at two fractions and you're adding them or subtracting them, okay, you look at the denominator and you try and find a common multiple. So a number that both these two can go into, that 11 can go into and 44. You're then going to place that number. So you draw a longer line and you're going to place that number at the bottom. So what number would that be? Number that both 4 and 11 can go into.
the easiest is 44.
Absolutely. Just do 11 times 4. That's the easiest way to find it. You're absolutely right. So we get 44. Okay. Now it's going to be the same thing, the same process with this fraction. So this is the denominator, that's the numerator. And I'm going to find the common, or sorry, the multiple that these two, both of them can go into. Now here you have rightly seen that we multiplied these two terms to get 44. Yeah, you're following? We're going to do the same thing because it doesn't change when we use letters. Now, what is x times y?
XY.
Very good. So that is xy, spot on. So that's going to go to the bottom. So now let's look at the other step that we take here. Then we say, how many times does 4 go into 44? Well, it's going to be 11 times. And that 11 is this number here because we multiplied the two numbers together. Yeah. So then you're
So
going
you're
to
gonna
take that.
multiply 3 by 11, right?
And then you're going to multiply the 3 by 11. Well done. So we're going to do the same thing here. We're going to say, how many times does x go into xy? Well, it's going to be y times, just as how it was 11 there. Then you're going to times the y by this first term. So here it will be 4 into 44 is 11, or in other words, simply 11 times 3, which is 33. And the same thing will apply here. I'm going to get this y, which was like that 11, multiplying with x plus 1. That is one term. This is all one term. That's like, think about this as that number 3, and think about this as that number 7. Okay? Then what's the next thing I do? Well, I keep the sign, and 11 into 44 is, well, that number. And then I times this number by 7 and I get 28. Well, it's going to be the same process here. The y into xy goes x times, in other words, this thing here, and I'm now going to multiply to that. Now there's a minus sign here, so I put my minus sign and I put my x, which is this x, and I have to multiply it by that term. So this is what I now have. Are you able to simplify this from here?
Yeah.
Okay, have a go and tell me what your final answer would be. So what would you do? Again, like I said, feel free to think out loud. How do you progress to manipulate this?
Wait, but since what I'm getting here is that you can only like scratch out the numbers like I did before in an equation, right? You cannot do that in an expression.
You can if the terms are common to the top and the bottom. So if I gave you an expression and I gave you something that looked like, I don't know, let's just think of 3x over 9x squared. Well, this here is an expression. If I ask you to simplify this, even though there's no equal to sign, you can simplify this because there's a common term, which is x in there and x in there. So the x's, one of them can cancel. So because this is the same as 3 times x over 9 times x times x. So the two x's can cancel. They're the same common term. X into x goes once. So your final answer would be 3 over 9x. So you can cancel common terms within mathematical limits. So if I had something, however, like 3 plus x, yeah, over 9x, this cannot be simplified. Yeah, so this stays the same. So you cannot simplify that. It is just as it is. You can't divide the x's off, or you can't divide the 3 into 9. Mathematically, that would not be allowed. But this here, mathematically, is allowed.
Oh, okay.
Okay. And another way to think about it is that if unsure, one thing you can do, Sayaka, you can think of these x's as being numbers. So imagine you gave this the number 5, just to give you an example. Yeah, you gave x the value of 5. Well, then this would mean 3 times x is there, 3 times 5 over 9 times, we said x is 5, so it would be 9 times 5 times 5. Now this here is 25. You've got a 5 there. The two 5s can cross out, so your answer would be 3 over 45. Now if we did the same thing with the numbers and we made x2, I would have 3 plus 2 over 9 times 2, which finally would give me an answer of 5 over 18. Now this would not be the same if I decided to cross out these 2's. I would not get the same number as 5 over 18. So that's another way of thinking about it. What would I do with the numbers? Whatever you would do with the numbers, you do with the letters as well. Okay? So of course I didn't simplify this one. Our final answer would be 33 plus 28, which would be 61 over 44. And we can then go on to simplify this, but let's not worry too much about that stage. I'm more concerned to see whether you can you manipulate this and simplify it?
I'm gonna try.
Yeah, good. I'll give you a little bit of a hint. So you have to expand the brackets. Have you done bracket expansion? Expanding
You
brackets.
mean just multiplying?
Correct. So if I gave you something like
Yeah.
5x plus 1, and I said expand this bracket,
Yep.
then what you do, you take this 5 and times it by everything in there. So your final answer will be 5 times x is 5x. 5 times 1 would be plus 5. Okay, so that is what you have to do here. You then have to expand each bracket. Okay, so that's a little bit of a hint for you there. Let's go to the next step and tell me what you get when you expand at the top.
You can, in the end, it will be yx plus y, because it will be like
very
y1.
good. So that's the first part.
But so like you can, they will be the same, so it wouldn't really matter. Right?
Will they be the same? I would almost expand them first. Oh, sorry, Sayaka. I'll say if I expand this, if we expand this, they will almost be the same, but not exactly the same, because this here, y times x, is going to give me xy. Let's just use a different color pen here. Will give me xy. Y times 1 will give me y minus x times y. What's that going to give me?
Oh, yeah, I thought you were like put it into brackets, both of them, and they will still be, oh, yeah.
Okay, no
Got it.
problem. So we're just expanding them there. So then minus x times y is minus xy, and minus x. What is minus x times minus 1?
Plus X.
Very good. So that is that top part expanded. I dealt with this bracket to get this term here. Then I dealt with this here to get that over there. And all of this is over xy. Now, this term xy minus xy disappears.
Yeah.
And so now we have our final answer as y plus x over xy, or you can write it as x plus y over xy. And that's your final answer.
Oh. Yeah, I wouldn't have thought about it that way.
That's absolutely fine, but these are the steps you would take if you were told to show you're working clearly. So you'd go from this step here, then you'd go to that step, and then you'd finally get to that step. So each of these steps, if you like, is a mark. So you'd have a mark for going to that step, one mark for going to that step, and one mark for arriving at the answer. Yeah? Okay, good. That is absolutely fine. All I just again wanted to check, this was really just to check where are you at with your algebraic skills. So this is all part of the check. It's a diagnostic. It's only meant to give me a starting place. Okay, right. Do you reckon you can do 2A?
Well,
And don't worry if you are not sure how to go about it. We might just park it, and then it will give me an idea of what else we can do.
is it minus X over 3?
Minus x over 3. Okay, now again, what you probably did here was you probably...
Yeah, I solved them when you sent it, and then you sent me the link. And now, since it's from back, maybe it's wrong, so.
That's fine. It's okay to make a mistake. That's not a problem. So I know what you did here. What you did was you crossed out the 2x squareds. Yeah. Well, there's a minus and a minus there. Minus divided by minus would be a positive. Then you did a 3 and crossed out the 9. Now you can't do that. Okay, so that's not allowed mathematically. That's absolutely fine, because again, how do I know that what I've done here has infringed mathematical rules? You can use numbers again to just verify that. So if I had made x2, let's just think about that. Well, what would this top be? X squared means 2 squared. What is 2 squared? It's 4. I've said that my x is 2. So this would be 3 times 2, which would be 6. What about the bottom part? Again, remember x is 2. So 2 squared is 4. So now I'll have minus 2 over minus 5, which is the same as 2 over 5. Which is the correct answer if you make x2. Now, if I'd gone about it in this way where you've done it, and I make x2, then your answer would come out as minus 2 over 3, according to this working that you've done, where you're crossing things out. You'd get minus 2 over 3, which is not the same as 2 over 5. So mathematically, you're not allowed, you cannot cancel them like that, okay? So again, for this one here, don't worry, special case. At least I just know where your level is on that one. But the key thing here to spot or do, you may recall learning about it, or may have not fully covered it yet. But here you would use a trick known as the difference of 2 squares. So x squared minus 9 can be expressed as x minus 3 multiplied by x plus 3. Do you ever remember learning anything like that? Yeah? What about x squared minus 16? How can I rewrite that?
But it would, okay, wait a minute. Well, it's not my dog. The dog is barking, so I'm
Okay, that's fine, Sayaka, not a problem. Take your time.
I'm really sorry.
I'll be waiting. That's fine.
I am so sorry. Um, so, yeah.
If you had to break this down into two brackets, what would you break it down to? Any ideas?
But wait a minute. You would be multiplying those things. So wouldn't it, at the end, you would also have a 3x, right?
Well, let's just have a look at that one. So it's a special case there. Very good question. Okay. Now this here we've said is x minus 3 multiplied by x plus 3. And if we expand this, I'm going to times this by that and this by that. And then I'm going to times this to that and then this to that. You happy with that? That's how we expand two brackets. So what is x times x? We're going to do the gold first.
X squared.
Good. And what is x times 3?
3x.
Okay. And what is minus 3? You need to take the sign times x.
Minus 3x.
Minus 3x. And what is minus 3 times plus
Minus
3? Plus 9.
Okay.
And now you notice that the two 3x's disappear and we end up with, sorry, this should be minus 9, I beg your pardon, because it's a negative multiplying to a positive. Sorry. Okay. And so these two cross out, and so you remain with x squared minus 9. What do you think x squared minus 16 will be? If we had to put it in two brackets.
You would have to have a decimal, right?
So for this one, you're not going to have a decimal. So there's a bit of a pattern here, and hopefully you'll spot that pattern. So this here now would be x minus 4 in one bracket and x
it will be
plus
4.
4.
I'm so sorry.
Yeah, that's absolutely fine. What about if I had x squared minus 25? What that
It will be 5. Yeah, it will be 5.
Okay, so two brackets, x minus 5 and x plus 5. So if we use that knowledge now here, we're going to express this x squared minus 9 at the bottom as x minus 3 and x plus 3. So that's this bottom part expressed here. What are we going to do with this? X squared minus 3x. Well, we can simplify this. This is the same as x, open brackets, x minus 3, close brackets. Because if I expand this.
I would have wondered how you would have done the 3. Yeah.
Yeah. So x times x is x squared. X minus 3 is 3x. So what I notice now is that the two x minus 3's are both at the bottom. And this here, because it's being multiplied, I can therefore cross out these two. So my final answer now, the next line is going to be x over x plus 3. Now do not cancel these two x's out, please, because this x is being added to something else. So do not cross out these and say my answer is therefore 1 over 3. That would be incorrect. So once you get there, that is it. You can't do any more, and you stop at that place.
So I can only cross them out when it's multiplied?
Correct. So if you have, you're absolutely correct. If you have x times y over, say, so if you have x times y, let's just say xy over 5x, then at this point, Sayaka, you can absolutely cross them out and say my final answer is y over 5, because the terms are multiplied, they're multiplied. But if you had now xy over 5 plus x, then do not cross the x's out. You can't do that. Does
Okay,
that make
I
sense?
think I understood that.
Okay, very good. Okay. I'm not going to make you do number 3. Don't worry about that. We are going to move on to forming equations, see how well you can form equations. So let's have a go at number 4. So this is where you have got stuff that's worded, and you have to form an equation and then solve it.
Okay. Okay, so it would be 2 and bracket x plus 4, the end of bracket,
Yeah.
plus x.
Plus x
Yeah.
in the brackets or outside the brackets, like the way I've written on the
Outside the
board,
bracket, yeah.
like this,
And
just above
then
it. Yeah.
equal to 26.
Equals to 26.
Yeah.
Okay. All right. So that's the first part. And then part B, solve your equation.
All right.
Yeah.
It will be 22 over 3.
22 over 3. Okay, so this one, I think you've just tripped a little bit on your manipulation, but don't worry. Now we can simplify this, can't we? The way it's written here. So you're very much on track, and to all extent and purposes, this equation can suffice, but can be simplified.
Yeah.
And if I simplified this, what would it be? Well, I'd have to open up these brackets, wouldn't I?
Yeah.
And if I open those brackets up, I'm going to have 2x plus 8 plus x equals to 26. It's not yet simplified because I can add the like terms. Yeah. And so I get something that would look like 3x plus 8 equals to 26. Now, when I come to solving it here now, so you have 3x plus 8 equals to 26. And we're going to group the like terms together.
It would be 18
the numbers
over 3, right?
will be together. So you may have made a bit of an error. Okay, what do you find as your final value for x?
I just completely forgot that 4 had to be multiplied.
Yeah, not to worry, but we're building the skills. That's what we're doing here. All right. So you're right. Then you take this to the other side. because it was a positive number here, it will then become a negative number at the other side. So now you get 3x equals 26 minus 8, which is 18. And so you get your x as 6. Okay, so x would be $6 that would be saved, or x is the value of $6. Do you follow that? Okay, so
Yeah.
much better on this one. Yeah, just a little bit on the manipulation. So that's good that you can kind of work with worded problems. That's something important for me to know. All right, goodie-o. What about something like this? Would you be able to do something like this? Again, if you can't do it, don't worry.
Mm. I have a question.
Yeah, go on.
If you have two equations, I
Yeah.
already have two equations, which is, but how do you put them together to find the cost?
Okay, again, don't worry. I'm going to go through that as a separate topic because it is a lesson on its own. So it's a topic called simultaneous equations. Do you ever recall doing anything like that in school?
No, I didn't.
That's fine. So don't worry again. We're just going to skip that one, okay? Because that's another topic on its own. I just wanted to see if you have an idea, but we're going to go through it. Definitely at some stage, I will teach you how to do these, all right? Because it's important that you know as part of your course. Okay, circles then, moving on to circles. Now, have you looked at areas and perimeters of shapes before? Good. So do you want to have a go at number 6?
Yeah.
Okay,
Yeah, I can.
no problem.
Mhm. Wait, I need to.
I'll make this a little bit bigger, just so it's a bit clearer. Yeah.
Oh, how would I know the radius of the little, like the circle?
Okay, so you would use a little bit of understanding of circle geometry here, but it's a good question. So that's a
Because I already know
semicircle,
the semicircle, the area of the semicircle, but I don't know how to get
not a problem.
the
So what's the
radius.
length from the center here to the end of my semicircle?
6.
Very good.
Oh.
So that's 6 centimeters. Now, if this is the center and it's been drawn at the center, what will
Oh,
this length be?
it will be 6 too. Okay.
Yeah, good.
Yeah, I understood, I think.
Good.
Yeah. Um, would it be uh
Go on, give it a try.
14.13?
Yay!
Oh, finally.
Nice one. Well done. Excellent. Good. Super stuff. Okay. And of course, you would have to put the units.
Yeah.
Okay. As with anything mathematical, you check out whether you've got the units. Well done. Good. Okay. Next one, part B.
Mm, I have a question. How do you memorize all the formulas?
Okay. Good. Good point. Okay. Some of the formulas will be supplied. Not all the formulas. You won't have to memorize each and every formula. Some formulas are given. Okay. But for one, common formulas that are worth remembering, and I shall give you these. They're not that many, okay, especially when it comes to areas and perimeters, okay? So for one, area of a circle, you know the formula rightly, correctly so, is pi r squared, yeah, and the perimeter, which is also known as the circumference, is 2 pi r. Now, the other versions of this formula you can use, whichever one is easier for you. So pi d squared over 4, where d is the diameter. This d is the diameter.
Oh.
And this r here stands for the radius. And you can also rewrite this here, c equals 2 pi r, as c equals pi times the diameter, because 2 times the radius, 2 times the radius is the diameter. That line
Yeah,
is
that
known as
helps.
the diameter. Okay. So
You.
these are, so this is involving circles. Okay. Now, of course, another shape that you need to know is that of a triangle. Do you know how to calculate the area of a triangle?
Yeah.
Good. Half base times height. Is that what you had in mind? Good. Now the area is
Too.
good. And then the area of a trapezium, that's another shape that you need to know as well. Okay, so those are the main types of shapes. Any other shapes will be composed of shapes like a square added to a rectangle, a circle, and it's just the same formulas. You're just splitting that polygon into those standard shapes.
Okay,
Okay.
understood. Mm. Okay, I think I have it.
Okay, good. And what did you get for that one?
34.26.
Okay, 34.26. Okay, not quite that, but let's look at it together because I'm sure there were some steps that you made that were correct. So the perimeter is the distance around something, isn't it? Yeah, if you're walking around it. So the first part here we see is, well, we need to know what this length is.
Oh, wait.
To there.
Oh,
Then we need to know
okay.
what this length is.
Wait, let me. They're both going to be the same.
Well, not quite. So this here, we can see this is half a circle. So it's going to be half of this formula here. Yeah, if I want to find this length here, that length in yellow, if I use this formula applies to a full circle. This is for a full circle. So if it's only half the circle, I need to divide this by 2. You're okay with that? Because it's only half I'm looking at here. You following?
Oh, yeah.
Good. So therefore, this length here is pi times the diameter, which is 6, and then divide by 2. It's going to be pi d over 2. Now, diameter is 6 centimeters, divided by 2 is 3. So that length here will be equal to 3 pi. Did you get that? Very good. What about this length here now? Let's try and work out what this length would be. Well,
the same, it will be divided by 4.
Very good. You're absolutely right. So if I take this now, that's my diameter, 12d divided by, so this here would be 3 pi. Is that what you meant, as in these are the same, yeah? That there to that. So this is also 3 pi, yeah? And now I know that I need to add in this length here. This length is 6 centimeters.
24.
So then I get in total, you're right, I get 3 pi plus 3 pi plus 6, which is 6 pi plus 6. Now, if I put that into my calculator, yeah, 6 pi times 6 plus 6, what's that going to give me? This gives me, or this here is 3.14, that value of pi. 6 times that is roughly 18 point something, 18.8 plus 6. So I get my answer as 24.8 centimeters. Okay, so far so good. Okay, excellent. Well, we've done a little bit then in that line on, I just wanted to see understanding on circles, which is good. I'm not going to go, so questions like these, have you done, just let me know, have you done questions like this? Just give me a little bit of a feel in the past. So looking at upper and lower bounds and accuracy.
Yeah, I have done that.
Okay, so that was under bounds. Okay, no problem. And then what about questions like this?
Yeah, I have done that.
You have also done that in circle theorems. Okay, no problem. I'm going to interspace some of these questions just on your assessment, but you've given me enough of a good feel to know what a good starting place should be. So,
but I don't really remember it, so
sorry?
I wouldn't mind. I don't really remember it, so I think it would be good to.
Would be, yeah, because it's one of those topics that's listed on your topic list there as well. So do you want to start off maybe with number 7 and just see how you tackle that one? Would you like to go through that one and then also go through number 8 and then
division, right?
Yeah, good.
But can we do the sequences thingy?
Absolutely, that is what I was going to move into if you want to do that. So it's what you want to prioritize. For me, I needed this preliminary session to get a feel for your strength. But of course, moving forward, now that I know where to pitch my lesson at, what it is you're good at, how well you understand fractions, how I should go about teaching you those things. But if you want to cover that, that is absolutely not a problem with me. We can definitely pick up pieces on there. So you want to, because those 5 sheets nearly that you sent to me. So I want to work out, I want to get an idea what it is that you want to primarily focus on. So you say you want to look at the sheet on sequences?
Yeah, we have been doing those. I think I can know about that one, but we have done right now, like today, actually, that's why I sent it so late, because today we did it. We did that one. I think I actually have it.
So is that the one, which says unit revision, sequences, proportion, and rational fractions?
I don't even know that.
because interestingly enough, I'm going to bring it through. I'm going to bring it through to the board, okay, and then we can have a look at those problems. So don't worry. I'm going to bring it into the board. G10 Unit 3 revision. That's the one we want. Okay, so I'm just going to bring this up.
Actually, the formative assessment number 2.
Import, sir. Oh, sorry, a different one. Is it the one? Did you email that today?
Yeah. I think it's called Criterion B Form 2.
Or criterion B? Okay, because there's also another one that you sent me.
Yeah, there's so many.
I know this is what I'm
Property
saying, as in which one do you want to start off with so that we work through these together. There is a lot, you're absolutely right. So criterion B, okay, so let me load this into my database here very quickly.
This one.
Okay, that one there. Okay, criterion B, all right, okay.
I kind of understood the first tasks, but I still have
Not sure
gaps.
for the
I have
second
gaps on
task.
everything, so it's kind of annoying.
It is,
But
okay. Don't worry, I'm just going to bring this through to my board so we can all have a look at it, okay? Import PDF, and it's Sayaka. So criterion B form 2, right, okay. We want it at the end of the current flip chart. Import. Right, okay, so let's just make this a bit bigger so we can all see what's going on. Right, so you're saying you have done the first task
yeah.
and you're okay with that?
Yeah. It was the easiest one.
It was the
So,
easiest one, right? And then they made it harder as it went on.
yeah.
Okay, not a
Honestly,
problem.
I started with this one because I started in the middle, which was kind of my mistake, I suppose, because I find it easiest to just rearrange this formula, and they said to rearrange it, so I thought it would be best to just start there.
Mhm, mhm, mhm.
But then I was just solving the one down, the number 10, and the
Oh,
teacher
so
called.
there's sorry, number 10. Is that number 10 you said?
Yeah,
I
number
can't
10,
see
and
number
he was
10 on
like,
my. Oh, there
I
is
think
number
you
10.
got it wrong. Yeah, I think you got it wrong because I put like the numbers and all that. I was like, you don't need the numbers. So I kind of redid it. But then he was like, have you done the first one? And I was like, no. So I went back. And by that time, almost all the time had gone like away. So I only could do task number 1. And when I started task number 2, I realized that it was not like task number 1. So I kind of, yeah.
Okay. So your teacher has reviewed task number 1 for you. So you
Yeah,
went
that
through that.
one, since I didn't have to do any the squaring thingy, so it was easy.
So it was slightly easy. Okay. So but did you start task number 2?
I started it and I
Mhm.
tried multiple ways, but it just, the higher it went, the smaller it got. I don't know how to say it.
Yeah, well, actually, as this gets bigger, what do we notice
Mhm.
about this as well? The numbers here, they're also getting bigger. Yeah.
Yeah, it's a proportional relationship. So yeah, but when I'm trying to do the equation,
Mhm.
since it's like a multiplication, but you have to get another one, then
Right.
I don't know how to explain it.
No. I absolutely know what you're saying, but generally what you say for this, we don't know what the relationship is here. Now, what you'd normally do that makes your life easy if you're given this is to draw a graph. Yeah, a graph would make your life very easy because then you can quickly see the patterns that ensue, if you understand where I'm coming from. Now, if I just look at this data here, we don't have a graph, but if you just think about it as a sketch, if you plotted a graph, okay, and this is your y-axis and your x-axis, and you had 2 values and your data did this, So in other words, you had data points that looked like this.
Or teacher, well, my teacher told me to use the formula y is equal to kx.
Absolutely, and that's exactly the point I'm raising here. So if it's a straight line, then this here would be the formula for it. He's absolutely right there, Sayaka. This would be of the form y equals to kx. Okay, that is if it's a straight line and all the points fit on that straight line. Now you can quickly check to see what the relationship is you have. On the other hand as well, I'm going to give you a number of ways of approaching these. There's more than one way of approaching it, okay? So if on the other hand, I plotted my values and my graph looked like this. And my points were scattered, or rather around this kind of, now can you see this is not a straight line?
Will
In
be
this
y is
case,
equal to kx squared.
correct. So in this case, the relationship y would be equal to kx squared, and your job would be to find that k. So the number of things you can do firstly to check if you have a directly proportional relationship. What is one of those things you can do? Well, at each point, the value, if it was a straight line, at each point, if you take your y and divide it by x, you must get a constant value k at each of these data points. So that's one of the things we can do to start off with, because we don't know. If it's not constant, then we're going to think of a relationship that looks something like that.
And
Okay?
how would I know which one is gonna be y and which one is gonna be x?
It doesn't matter which one you use. It really does not
Oh.
matter. That's the beauty of it. Okay?
So I can put g as an x or as y?
So you can put, you can use the G as an X and the
Oh.
V as a Y, or you can even use this here at the top as your Y and that as your X. Doesn't matter. Okay, so far so good. All right, now if I just, where's my calculator? Have you got your calculator there?
I leave it at school.
That's
I'm gonna
fine.
pick it from home.
That's fine. You can use the one, of course, you got the one on your phone. So if we just do it the other way and do a y divided by x, yeah, we're going for this just to see. So we're going to be going for, so forget about these here in purple. We're not using this here as our y. We're using this as our x value and these as our y values. Okay, so there we go. Now I start off and I'm going to do a y divided by x. So I say 102.4 divided by 32. And I get 3.2. I'm going to write these at the top.
Yeah, you get 3.2.
And then I do 160 divided by 40. Well, I get 4. And then I do 202.5 divided by 45. And then I get 4.5. Well, this looks like it's increasing, surely. Yeah, it's not a constant. So this here, these values here are my y divided by x, by the way. And I'm just going to put this in tabulated. So this somehow is telling me, it's not maybe necessarily a y equals to y over x equals k, because the k I'm finding here is not constant. It's 3, then it's 4, and possibly over here, it might be 5 point something. Yeah? So what could I then try? So use the pattern and determine the proportion between the verb, and then represent this relationship with a formula. So what other thing could I try? Well, it might be this type of relationship, in which case then y over x squared must be a constant. I've just rearranged this here. So far, so good. I've rearranged that. So now if I do the same thing and I repeat, now I'm going to do, so this top part here is going to have my y over x squared. And I'm going to try and see what that leads me into. So it's a bit of a, yeah, an investigation being carried out here. So then I say now 102.4 divided by brackets 32 squared, because that's my x squared. This gives me 0.1. And then I say 160 divided by 40 squared. This also gives me 0.1. And then I do 202.5 divided by 45 squared. This also gives me 0.1. So now the constant I'm getting is the same. This is my constant, K, in each of these cases. So it can't be a directly proportional relationship. It therefore, sorry, a directly proportional relationship to X. It is directly proportional to X squared. That's the relationship I get. So now I know that in this case, we can rewrite this and say that V is directly proportional to G squared. We've seen that V is directly proportional to G squared. Following so far?
Yeah.
Yeah. And the next step to my solving this, because it says use the pattern above and to determine the proportional relationship between the variables, then represent this formula with a formula. Show all your work clearly. So here I've shown my work in that I tried to use y over x, and I saw that the constant k was changing. So I knew it can't be a straight line relationship. Then I used y equals kx squared, and I see that I've got a constant k. And of course, then my next step would be to say that v, pardon me, must be equal to, I introduce a constant k g squared, kg squared, okay? But that's not the end of the game, because I need to work out what v is, don't I? Sorry, what k is. And I've already worked out what k is. Where did I work out what k is? I worked it out here.
0.1.
Yeah, so k is 0.1. So therefore, I can finish off my answer and say, right, sorry. Therefore, v is equal to 1 over 10 g squared, or g squared over 10. Or you can write 0.1 g squared. Any of these will be acceptable. Did you follow that okay?
Yeah.
Yeah? Do you also understand this step we took here, why we were dividing x squared by y?
Yeah.
Yeah? And remember, just to convince yourself, you could have also used this as the y and this as the x. You'd have still come up to the same thing. Only this time now, you'd be squaring that. Does that make sense? Yeah, so you'd be saying y divided by the square of that. So the k values are going to be different, because now what you're going to have, you're going to have a relationship that's going to say, if you're dividing by that, you're now going to have a relationship that says g, but now you'd be using a square root relationship. And just as a bit of a hint, generally speaking, Sayaka, generally speaking, the top part represents x and the bottom represents y. Okay? If your table is given like this. If your table is given like this, and it looks something like this, and you have, I don't know, h, or let's just say t, and you have h, and you've got some values in here, I don't know, 5, 80, 360, just giving an example. Then, generally speaking, these will represent your x values, and these will represent your y values. Because normally in science, when you draw a table, what goes in first is what we call, now have you learned about variables, independent variables and dependent variables?
A little bit about it, yeah.
Good. So this here is the independent variable. It's what we change. And this in this column, so we always start off with our independent variable, which in other words, our X values, and the Y is what you measure. So you put that in the second column. So we made the right approach by treating this as X and this as Y, even though of course you can interchange them, but it's generally much easier to work from there. Okay, are you okay with that?
Yeah.
Excellent. Right. Oh, use your formula to find the value that should go into the blank box. Now you should be able to do that once you've gotten hold of that formula. Yeah.
All right. Yeah, since it's gonna be y is equal to 0.1 x is your own value that should be written in the blank box.
So sorry, you might want to go back to this so you can see that.
Don't worry, I have my copy.
Oh, you've got your copy. Sorry. Yes, of course you do. You do. Yes.
It's gonna be
Okay. What did you find as what should go in there?
I wouldn't know my x, right? So yeah.
Yeah.
I'm using my calculator.
That's fine.
X will be equal to 100, right?
Spot on. Well done.
Wouldn't it?
Yeah. You're correct. You're spot on. You're absolutely spot on. Good. Okay. Right. Done. Now, task 3. Did you do task 3?
No, I didn't even read it.
Oh, so you only said you only got as far as task 1 in class. Okay. All right.
Oh, well, I did task 1 and task 4.
Task 1 and task 4. Right. I got you. So you've done task 1 and task 4.
Yeah, I
So
kind of just like breeze through it, and I just kind of usually stay in the harder part because
okay.
if
Were you okay for task 4? Did you work through task 4 fine with no problems?
there were problems, but I only solved 8 and 9.
That's fine. So you want us to look at task 4 as well?
It would be nice.
Yeah, good. Okay, so let's go for task 3 first. Make sure we can do task 3. Okay, and then we'll move on to task 4. So I want to give you a go first. Have a try at looking at it and seeing what you could do and how you'd approach it.
Yeah, I also need to check I'm having another formative tomorrow.
Okay,
So
okay.
it's gonna be criterion D, which I haven't done yet, so I don't have. So I think it's gonna be based on the G10 unit revision.
So do you want, so once we've done this, so you're going to want to go through the G10 unit revision.
Yeah.
Okay, let's try and squeeze in. Okay, let's try and work as quickly as we can then. So we try and squeeze in as much as we possibly can. Okay.
If we
That's
can't, it's
absolutely
fine. I already kind of get. I actually can understand criterion D a little bit better than
Oh,
criterion B.
good. Good. That's fine then. All right. So we've got task 3 then when you're ready, Sayaka. Okay.
Pressure P and a special substance. Where is inversely as the cube of radius. How inversely will be y is equal to k over x, right?
Very good.
So it will be y will be p and x would be r, right?
So y would be p and x would be r. You're spot on.
So determine the effect on p if the radius becomes 6 times larger. It would be p is equal to k 6r. But apart from that, I don't know how to continue.
Not sure how to continue about that. So you have written, let's see what you've got. So you have said firstly, so P varies inversely with the cube of the radius. What does cube mean?
That is 3.
Okay.
I mean, the 3 is
absolutely. It's been raised to the power of 3. Okay. That's this sentence here. I've written it in algebraic terminology. I've only just written the sentence, so I'm not yet. Yeah. Now it just says here, determine the effect on P if the radius becomes 6 times larger. Now this also means, of course, that we can rewrite this and say P is equal to K over R cubed. K is a constant number, so you need to visualize it a little bit here. Let's just imagine that K is 1. Let's just to understand the problem. Let's imagine K is 1. So now we have P equals 1 over R cubed. We've just made K 1, just to understand the problem. So now I'm going to get R. So it says if the radius becomes 6 times larger, let's imagine that our starting radius is 1 centimeter. Oh, just 1. And we make it 6 times bigger. Now that's 6. That's my radius there. And that's my radius there. Okay, this is before. And this is my after. So at the moment with the radius equals 1, I just put 1 there. So the pressure is 1. So here, the pressure is 1, is equal to 1. What about here now when the radius is 6 times bigger? So it's now 6. What would the pressure be here? Any ideas?
It would be, wait, I have to.
So we simply use this formula here.
It will be 1 over 216.
Very good. Now, determine the effect on P if the radius becomes 6 times larger. Well, P has been reduced by what factor? By a factor of 216. It was 1, and now it is 1 divided by 216. So when this radius becomes 6 times, the pressure drops by a factor of 216. Did you follow that? Now, it doesn't matter what value of K. You could have also spotted that here, all right, without drawing these diagrams. How could have you done it? Well, if I have a relationship, just to give you an example, that is 1 over V squared. What this means here is that if I double this, if I make this 2 times bigger, this thing here will reduce by what factor? It's going to reduce by a factor of 2 squared by 1 over 2 squared if I make this double. What about if I triple this? I make it 3 times bigger. Then P the new P will reduce to 3 squared. If I make this 4 times bigger, because of that squared, so this is if I make it 2 times bigger, the pressure is going to quarter. If I make this 3 times bigger, it's going to go down by 1/9. If I make it 4 times bigger, okay? Likewise, the same thing happens here. If that said, if P is made 2 times bigger, you'd have simply said 1/2 cubed. You keep that. So it means that it would reduce by a factor of 1/8. But because it's gone 6 times bigger, it's going to reduce by a factor of 216, because you do the 6 cubed. Did you follow that okay, Sayaka?
If I have P is equal to K over 6R cubed, the R being cubed, how do I continue from that equation? Like
if you've got this part here,
if I have P is equal to.
so are you okay with what answer you firstly put down here? Oh, sorry,
Yeah.
you sent me a message through the chat.
Yeah, just the equation.
Oh,
And
P
P will
equals
be the
K
cube.
over 6R cubed. Good. If you have that, yes, go on. Your question was, how do I continue?
Yeah.
There's nothing
How do I
more here,
prove?
more than to show that if you increase this by, so this is what it is at the moment. P
Oh, so to prove
equals,
it.
well, it
Oh,
says,
sorry.
yeah, you're not actually proving anything. So P is equal to K over R cubed, okay? If R is made 6 times larger, well, it means now that this is no longer R cubed, because the R is now 6 times bigger than R. By the way, this is the word if. Okay? So it means that the new pressure, if R is made 6 times larger, new pressure will be P, and we can say P new, if you like, is equal to, the K doesn't change, but my radius is now 6R, and I need to cube all of this. That's the step in your calculation. So my new pressure would be equal to K over 216 R cubed. And if you compare the new pressure divided by, if you compare the old pressure, let's call this P old, because this was the old pressure when R was just R. Here we've made R 6 times bigger than R. So P new divided by the P old, because it's determine the effect, divided by P old is going to give me, well, I need to take this and divide by that. So K over R, sorry, the new one, I beg your pardon, determine the effect on P. You can do it in either way, P new divided by P old. Without trying to confuse you here, Sayaka, what I'm saying is, can you see that the new pressure, very important that you see that, is the same as the old pressure, because this here represents the old pressure. This term represents the old pressure. That's the old pressure. And we've taken the old pressure and divided it by 216. Can you see that okay?
Yeah.
Good. So therefore, the effect on P, therefore, P will be reduced by a factor of 216.
Yeah, I understood.
Good. Okay, number 7 then.
When pressure is 8 times larger, what happens to the radius? Determine the effect of the increase on the radius. Show all your work.
Any ideas how to go about that one now?
You start the equation again with 8p is equal to k over r. Determine the effect. Oh, r cubed. Yeah, increase in the radius. Show your work. Then in that case, I would still put well, let me try it.
Yeah, no problem.
I'm not entirely sure.
Okay, a bit tricky this one, a bit challenging. I can see why you might find this one a bit tricky. Okay, so if we write this out as, we know that P equals to K over R cubed. Yeah, all right,
Yeah.
good. So therefore, we can rewrite this and make R the subject of the formula. So rewrite a formula because they want us to think about what happens to the radius. So can you rewrite this and rearrange this so you make R the subject of the formula? What do you get?
So
Meaning, I want an
just
equation that says R is equal to.
okay, let me. You would put. Okay, I don't know how to.
So it would be
It would
R
be
equals
r
to
is equal to and the
square big root sign.
a root sign, and it will be k over p.
K over P.
And
Is
the
that it?
root that will have a small tree.
A small 3, very good. And this is what we call the cube root, okay?
Oh.
And you can rewrite this as cube root of K at the top over cube root of P at the bottom, okay? So far, so good.
Yeah.
Now, this cube root of K is a constant number. K is a constant number. That's the key thing to remember. So the cube root of K will also be another constant number that doesn't change, okay? We can call that new constant number, which is the cube root of K, because K is an actual number. So cube root of it will also be an actual number. We can call that number, and give it a new letter and just call it A. You're allowed to. And therefore, we can rewrite this as A, where A is root 3 over K, divided by cube root of P. Okay? You happy with that? Good. Now, let's just think what happens here. If this is 8 times larger we're going to need a new page here. Insert a new page after current. So we've got this formula that says R is equal to some constant A. We know that A is the cube root of K. We've decided to make our life easy, over, and we've said that the cube root of P, now the cube root of P
would have an 8.
very good. It would have an 8. So now if I cube root 8, what value do I get? If I cube root 8, so what's the cube root of 8? So this is going to have a value of 8.
Yeah.
What do you get if you cube root it?
Let me just use my calculator. 512.
Not quite. If you cube root 8, not if you cube 8, if you cube root it, 8 to the power 1 over 3. This is what we're looking at here. We're looking at this, not this.
1.7.
Take your time again. So the same number that if you multiply it by itself 3 times, you get 8. What number would that be? The cube root of 8. One number which, when multiplied by itself, x times x times x equals 8. That's what the cube root of a number. What number would that x be?
2.
2, correct. It would be 2. So the cube root of 8, which we also represent as 8 to the power of 3, is 2. Well done. Now, this is telling you that this has gone down to 2, so it becomes a over 2. What do you think has happened to the radius therefore? What must have happened to the radius for the pressure to increase? Remember, they are inversely proportional. So the pressure has increased. What do you think has happened to the radius? And by what factor has the radius changed? So inversely means when something goes big, the other thing goes small. Good. So now I'm just saying the pressure has gone up 8 times. What do you think has happened to the radius?
It has gone down.
Very good. It has to have gone down. By what factor has it gone down?
By 2.
Very good. That is the factor. So in other words, you've reduced the radius. And if you go back to your original formula here, which is this here, P equals K over R cubed. If you halve this, so now you're going to get R over 2 cubed because you've halved it. You're going to get K over R cubed over 8. And this 8 here times is going to then times or multiply to the pressure, which is going to increase the pressure 8 times. Did you follow that?
Yeah.
Good. Okay, okay. Right, so it's up to you. Do you want to go through task 4, or do you want to go and start looking at other criterion? Is it D or B?
D. I think it's better if I go to that criterion.
Or you want to finish this one here, task 4?
No.
You sure?
Other.
Are you absolutely
Yeah.
sure? So you've done 8 and 9, and you've only got, oh, there's only one question left, which is 11 on this one. So it's up to you, Sayaka.
On weekends, right?
Sorry?
We have another meeting on the weekend, right?
Yeah, we've got another meeting on the weekend. It's just for your test tomorrow, what you might want to focus on your assessment tomorrow. That's what I was trying to help you with.
The assessment tomorrow is going to be criterion D.
Criterion D. And we've just been looking at criterion B here. So should we pull in criterion D then?
Yeah, I
And
don't actually have only a criterion D exercise because they cannot give us that. It would be like cheating or something, I guess.
yeah, but
But
you've
the
got a
rest of
revision
them,
list that you were sent, isn't it? Unit revision sequences, proportion, rational
yeah.
fractions. Yeah, I'll bring that up, okay? And then we'll
Yeah,
have a quick
thank you.
glance
I
through that.
think on the weekend one, we can finish this one because the
We can
summative,
finish this stuff on proportions.
yeah.
So we can look at task
Uh,
4. Okay, no problem. So if I just import file and import PDF.
I have my summative, the criterion B summative
Mhm.
on Tuesday or Monday. It will probably be changed for me because I'm not coming on Tuesday.
So you've got a bit
Uh,
of time. So your criterion B summative is next week.
yeah.
Yeah, and so what we're looking at now, which is the G10 unit revision, that is for the one tomorrow.
Uh, the one tomorrow is my formative criterion
Okay.
D, and I'm gonna have the summative of criterion D
Okay.
on Friday. Not
Okay.
this Friday, the next Friday.
I see. Okay. Right. Anyway, so we've got this in front of us. So this is the G10 aspect of it. Have you started looking at this already?
Yeah, I already solved it, but I didn't really understand anything of
Oh, really? Okay. 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 So you've done all the questions here then.
uh yeah. All the things that I have sent, I already done it.
So did you do questions and have you marked the work? In other words, do you know whether you're correct or not?
They don't really mark it. They only mark formative and summative.
Yeah, okay, that's
Actually
absolutely
haven't.
fine. So, but for me then, I need to know, is that it? I need to know how well you've understood it. So I need to kind of see whether you've grasped the concept. So do they,
Have it here.
okay.
Um
So what did you get then for number 6?
oh, number 6, it was the easiest one.
You found that easy?
Uh well I kind of
Okay, what did you get for number 6 then?
the first one I got 2/5.
2/5. Now, there's something else it says here.
Is that incorrect?
Date. I don't think it's correct. I've not done it, but I've just got a feeling by looking at it that I don't think you're right with what you've done. That's the first thing that comes to mind.
No,
Because
it's
also,
2/.
you've not stated the restrictions
Oh,
on the variables.
what is the restriction of a variable?
Okay, so that's a very, very good question. So if I have, first I'm going to ask you just to make sure you understand. We're going to start off with, what is 0 divided by 5?
It will be 0 divided by 5.
Yeah,
It will be 0.
very good. Not a trick question. What about 5 divided by 0?
5.
Not quite. 5 divided by 0. Well, 5 divided by 1 is 5. What is 5 divided by 0?
0?
Not quite. Try
Really?
put that in your calculator. Try use your calculator and solve 5 divided by 0.
Not a number.
Exactly, because this here is impossible to do.
Why?
5 divided by 0 is impossible.
5.
There's no value. Even your calculator will not give you a number. It will say, maths error, I cannot solve that. Because it's impossible to do. You cannot find the number of times that 0 goes into 5.
Oh, right.
Yeah? 5 goes into 0 times, but how many times does 0 go into 5? It's impossible to solve that. So the restrictions, anytime, so if I gave you an equation here that was written as 5 over x minus 3, what are the restrictions on this equation? Well, we cannot let this bottom part equal 0.
We cannot what?
We cannot let this denominator, the bottom part, ever equal 0, because if it equals 0, then I'm going to have that situation of 5 over 0, which is impossible. So the restriction I need to place on this is that x minus 3 cannot be equal to 0. Therefore, x must not be 3. If you put the number of x as 3 in here, you cannot solve. So x cannot be equal to 3. Because if you put 3 there, it's going to be 3 minus 3, which is going to be 0. And then you're going to have 5 divided by 0. So this is the restriction. X must not equal to 3.
Oh.
What's the restriction here? Well, this should not equal to 0, and this should not equal to 0 either. So 5x minus 5 must not equal to 0. And if I solve this, minus 5 goes there, it becomes 5. 5x divided by 5 divided by 5. So we say that x could not be equal to 1 in that case. That's the restriction on this bottom denominator. X cannot be equal to 1. Because if x is 1, 5 times 1 is 5. 5 minus 5 is 0. Whoops, we end up back in that situation. Now, what's the other restriction going to be? Can you tell me what the restriction will be for this denominator now?
Wouldn't it be the same one?
No, it won't be the same one. So see what you do firstly. You take that expression and you make it not equal to 0, and then you solve it how you would solve an equation. So can you tell me, just like what I did here, I made x minus 3 not equal to 0. I solved for x. Now, can you solve this and equate it to 0 and tell me the value of x that will make this denominator 0? Definitely won't
The
be
value of
1.
x that would make this denominator 0?
Yeah.
I'll try. Minus 2?
Correct. So what's the restriction? X cannot be equal to minus 2. That's the restriction. That's what we mean by state the restrictions. Okay? And you do the same for each of these here. All right?
Oh.
So let's just state the restrictions firstly for each of these before we even go into solving them. So what would be the restrictions for the second equation and the restrictions for the third equation?
For the second equation then. Five.
Very good. 5. And that is for this part here. So x must not equal 5. And in that one there, what would it be? It would be 5 as well, wouldn't it? Nice and handy. So again, for this one, x must not equal to 5. What about this one here and that one there?
Minus 3 and...
Yeah, in both of these, it's minus 3.
Oh.
In both those cases, x must not equal minus 3. So these are the restrictions. So now that you're done with the restrictions, okay, I'll just erase this. Now you got 2/5 for the first one. Now I've got a feeling you may have gone wrong somewhere. So let's look at it together and then I'll see how you've done these ones as well. So here we go. We have 4x plus 8 over 5x minus 5 multiplied by 3x minus 3 over 6x plus 12. Now, what are we going to do with this one to solve this one? Yeah, same piece of, or same idea, the common denominator. Sorry, oh no, that's times. So not even common denominator. Sorry, that's not even a plus. This is times. So you need to take the two brackets, 4x plus 8, and multiply that by 3x minus 3. And at the bottom, deal with the 5x minus 5. And this, of course, here times by 6x plus 2. So you're going to have to, oops, take a different color. This will times with that. It will times with that. And then the 8 will times with this and times with that. That'll be for the top part. Likewise, we do the same for the bottom.
Okay.
So do you want to do that and see what you get?
Yeah, I'll do it quickly.
Okay, no problem.
I'll try to do it quickly.
Okay, that's fine.
Okay, so we so above
Yeah.
would be 24x minus 24.
Okay. 24x minus 24.
Yeah.
Let's just check that one. So 4x times 3x would give us 12x squared.
Minus
4 times that will give me minus 12x. 8 times 3x would give me plus 24x. 8 times minus 3 would give me minus 24. That's the top. The bottom, 30x squared plus 10x.
Minus 30x.
Yeah, minus 10. And this here will make, in total, like terms, it will get 12x.
Yeah, never mind.
And this, not to worry, this here will make minus 20x. Yeah? So now I have, if I rewrite this now, I now have 12x squared plus 12x minus
Yeah.
24. Is that what you got?
I changed it. And the one below is 30x squared minus 20x minus 10.
And absolutely right. This is 30x squared minus 20x minus 10. And we can simplify this because here I can see that I can factor out a 12 because 12 can go into all of these things. And I have x squared plus 1 minus 2. And at the bottom, a 10 can come out. And I have 10. Sorry, this should be x here, beg your pardon. Yeah. And this here is 10. And I get x squared minus 2 minus 1. So far, so good.
Well, wouldn't it be 2x?
I need a 2x. Thank you. I'm rushing it.
I'm
2x
using
minus 1. Yeah. Okay. Now you can simplify this because 2 can go into 10 5 times. 2 can go into 12 6 times. Yeah. And you can go even a bit further, can't you? Can you go a bit further?
Yeah, by multiplying, I suppose. But you can
We
also
can put
cross them
2,
out.
but as it is, say, simplify each rational expression. We have simplified it, x squared plus x minus 2 over x squared minus 2x minus 1. But we can go a step further here if we wish to, because this here, x squared plus x minus 2, this can also be simplified. Yeah, if you've got a 6 on the outside, as what would that be? X, so x minus 2, so that would be x plus 2, x minus 1, this here. And the bottom part with my 5 there, so that's x squared minus 1. Ooh, can we simplify this any further? X minus 1, no, this can't be simplified any further. Yeah, so it's always worth a check to see if you can simplify this any further. So what we've got here now is x squared minus 2x minus 1. We can't break that down into 2 brackets, can we? Because I'll need to find 2 factors of minus 1, which is 2 factors of minus 1 is minus 1 and 1. And if you add them, you don't get a minus 2. So that would be as far as we would get with this one, 6 over 5, and then these terms at the bottom. So this would be my answer.
Can I share my screen? I have the answers of my teacher here.
Yeah, okay, go for it.
I will have to stop your
Yeah, that's
screen.
fine.
Is here. Is this 2 over 5? Is it wrong?
What have they got? X is 2 over 5. Hang on. So if we just go up, x as 2 over 5.
Oh,
I'm not getting 2 over 5 for that one. So what's he done then? X minus 1, x minus 1. Those have crossed out. 2 over 5. Okay, so the restrictions are there. Okay, so we may have just tripped up somewhere. Do you want to go back to my screen? If I go back to my screen, we should all end up at the same answer then. So I've just made a slight error somewhere, as we all do with these things sometimes. Okay, so that's fine. So we can review it from here again, just to double check. 5x minus 5, 6x. Can you see where I've made a mistake? I used 2 here
you're not
instead of
sharing
12.
your screen.
Yeah. So that's why I made a mistake. So this here, therefore, should be minus 5, and this there, that should be 60x here.
Teacher?
Yeah. So that's the
you're not
30.
sharing your screen.
Oh, sorry. Sorry if I
It's
go
fine.
there. Okay, share screen. There we go. And you should be moving ways. Okay, so this here should have been 60x. Okay, and then this here is still minus 30x, and then there this would be minus 60 here. Yeah, so now if I do this 60 minus 30, this will be plus 30x. Yeah, with a minus 60. So I now have 30x squared plus 30x, okay, minus 60. And now the number I can take out here is a 30. 30 can go into all these numbers. So this number here at the bottom should actually be a 30. Sorry, there's a bit much going on here, but if I just take this off, there we go. So this should have been a 30 on the outside, and this is still a 12 because I'm fairly certain we're right at the top. And now this is now x squared plus x minus 2. In other words, I'm going to rewrite it here. Sorry, there's a lot going on. I've now got 12 over 30 x squared plus x minus 2 at the top, and I've got x squared plus x minus 2 at the bottom. Because this is timesing with that, and this is timesing with that, and these are the same, I can cross them out. Yeah? And now what is 12 over 30? Well, what number can go into 12 and 36? 6 into 12 is 2, 6 into 30 is 5, and so the answer is 2 over 5.
Yeah.
Yeah, we got there. Okay, right. Now,
I don't think we have time. It's
we've
fine.
got a
It's
little bit
fine.
of time. I'm adding on a little bit of time because we did have that moment where we lost some time when I had to send you the link and all of that. So we've still got another about 4 or 5 minutes left.
Oh, thank you.
Yeah, that's absolutely fine. So which one of these would you like to then review of your criterion be? Any other particular question you want to look at together just to get some commentary?
Maybe 5.
Number 5.
This is the one above.
So it says the developers of a new social media website think that its membership will grow by the same scale factor every month. At the end of the first month, it has 20,000 members, and at the end of the second month, it has 25,000 members. Explain which information. Sorry.
Oh, sorry.
Go on.
Sorry, I keep interrupting you.
That's
the
fine.
scale factor, the same scale factor will be K, right?
The same scale factor in this case, yeah, you're going to choose a particular scale factor, which you can call K. Yeah, correct.
I just wanted to make sure.
That's absolutely fine. So explain which information in the statement above suggests that this sequence can be modeled with a geometric sequence. Which information, or which information in the statement? For part A, which one would you say would your answer be? Explain which information in the statement above suggests that this can be modeled by a geometric sequence. Which statement in here do you think?
That it will grow by the same scale factor every
Very
month?
good, absolutely spot on, Sayaka. By the same scale factor every month. That's that statement. Okay. Then it now says, determine how many members this model would predict for the website to have at the end of 12 months. How do we do that then?
You will have U12 is equal to U12 is equal to, what was the geometric sequence?
So for your geometric sequence, your formula looks something like A R to the power of n minus 1. So this here is your common ratio.
So So it will be K.
Sometimes known as K, yeah, or your scale factor. K, correct. So you can rewrite this as well as a K to the n minus 1. Is that how you write it?
Not really, but it's easier to memorize.
That's fine. Okay, good.
The
Okay.
A will be the number, like the sequence number.
Yeah, so what would A be in this case?
It will be 12.
Okay, just take your time.
Right?
12?
Yeah.
No, read it very carefully.
Mm,
That its membership will grow by the same factor every month. So at the end of the first month, it has 20,000. At the end of the first month, it has 20,000. At the end of the second month, it has 25,000 members. So how did you work out what the A should be? I'm not saying you're wrong, just trying to explain it to me so I understand how you got there.
so U1 will be 20,000. U2 will be 25,000. Right?
So you're saying U1 would be 12,000.
20,000.
Oh, 20,000, right. Okay, so U1 is 20,000 and U2, I got you.
U2 is
Okay, so I
25,000.
thought you said 12,000, sorry.
No,
And that's why I was
no,
asking how you got 12,000. Okay, so U1, first month, we start off with 20,000. Second month, we have 20. So the A is saying this here is my A, yeah? Okay, what's my common ratio, my K?
Your common ratio would
In other words, what's my scale factor?
let me find out. I
Okay.
think I know how to find it, but
So to find it, the common ratio, or K, is you can use the succeeding term, UN plus 1 over UN. What this means here is if this is the second term, you can divide the two.
25,000.
25,000 divided by 20,000. What does that give you?
1.25.
So 1.25. So that's your K. So your formula now looks, what does your formula look like? It looks like this. 20,000 multiplied by 1.25 to the power of n minus 1. Does that make sense?
Yeah, it makes sense.
Good. So now you can use this, because this is now for our general term, the nth term.
Yeah,
Now
so
you can use that to work out how many members the model would predict to have at the end of the 12th month, where now your n would be 12.
Yeah.
Okay.
$1.25. I think I got it wrong.
Yeah, what did you get for that one?
Yeah, it's wrong.
Okay, what answer did you get? Just to share it if you don't mind.
I did it in a calculator, right?
Yeah.
But since it's the computer calculator that I never use, I don't know how to put the 11 like as a square.
Okay, so you've struggled with that
I
one.
don't know
Okay.
if it might have impacted it, but what
Yeah,
I got is 232,830.
which is the answer. Yeah, it is
Yeah,
the correct
which
answer.
sounds what?
That is the correct answer.
Oh, what? Oh,
Yeah, you can check it in your answer sheet if you want.
yeah, maybe I should.
But that must be the correct answer. So you've got 232,830. Okay. Or since it's people,
Oh, yeah.
then 831. Yeah.
Yeah,
Okay.
that's
So
what
you're
I.
absolutely spot on the money. So your calculator has not let you down. Worry not. All right. So determine how many members this model predicts for the end of the second year. What would you do then for this one? What would your N be?
Uh, the second year. Oh, okay.
Yeah. For the end of the second year.
I will be 3,388,132.
It's a big number. Yes, absolutely spot on. Okay,
Uh,
good. So that was on that one. We've done some geometric progression, but also done a little bit on algebra, which was important. But that does
how do you
bring us,
know?
go on.
Oh, how do you know when is a geometric sequence and when is an arithmetic sequence?
Okay, that's a good question. So for an arithmetic sequence, okay, the numbers increase by the same amount. Yeah, so if you subtract one of the two numbers, so if I add 1, 3, 5, 7, this here is an arithmetic sequence. The numbers are increasing. There's the same difference between two successive numbers. So same difference between successive numbers. Okay?
Yeah.
If it's a geometric progression, so it's going to go something like 1, yeah, 4, oops, 9, 16. Can you see here? So here the difference was 2, 2, 2. If I look at the same thing now for geometric progression, and I look at these, well, what are numbers here? 3, 5, 7. Can you see it's not constant? So this here is a geometric progression. I'm just going to say GP.
But in the question, it says the same scale factor every month.
Absolutely. And the same scale factor, if you look at these now, they've got the scale factor, if you like, because it's a geometric progression. Yeah. The ARN minus 1 factor itself will be the same, so to speak, if you're looking at it from, what's the other way? So, you're asking from, if the question is worded, you're saying, if the question is worded, as opposed to you've actually given numbers, because it's easy when you're given numbers, because you can just look at the differences, isn't it? I get you. So you know that. That's easy if you're given numbers. But the key term here, they're saying it will grow by the same scale factor. Now, a factor is something that you multiply to something.
Okay.
Okay. So if I say increase 8 by a factor of 5, increase 8 by a factor of 5, it means I'm telling you to do 8 times 5. If I say increase 8 by 5, then I'm asking you to do 8 plus 5. So the word here,
Oh,
factor, can you see the difference?
yeah.
Yeah. So if you increase something by a certain number, you just add it. But if you increase something by a factor, then you times it. So that is how you'd know that you're looking at a geometric progression. Is that okay?
That yeah. Thank you.
Perfect. You're most welcome. So Sayaka, next lesson then, which is on the Sunday, any chance we could start a little bit earlier? So when I say earlier, if we could start, so we started at 8 today. Can we start an hour earlier? So instead
Yeah.
of the time we started today, just 1 hour. So what time was it over in Japan when we started? Was it about
It
5
was at
o'clock?
5.
5.
Yeah.
So if we start at 4 p.m., would that work for you on the Sunday?
Yeah. I'm honestly free the whole day, so I'm free anytime if it's better for your schedule. I
Okay,
wouldn't mind.
great. I've got your email anyway, so we'll be able to liaise if need be. So what do you want to focus on the Sunday?
Since I have my criterion B submitted,
Yeah.
maybe I should practice my criterion B.
Criterion B, yes. And so criterion B, because I'm sorry, I'm getting lost on the criterions here. I'm still trying to
Yeah,
get my head around the criterions. So criterion B was this,
is
isn't
that
it?
one? Yeah.
Criterion B. That's fine. Okay. All right. So you might want us to do a little bit of criterion B work on um on Sunday.
Yeah.
That's absolutely fine. Well, we've got 2 hours, so we should be able to squeeze in quite a bit of work, and then we're going to look at how you get on with this as well. Okay, task 4. And do you have any other further questions on criterion B that you've been sent to work through?
Really? But I will. Do you have exercises for
Yes,
criterion?
absolutely. I shall send you. That's the reason why I was asking. So if you don't have any further exercises, so you want me to give you work, or particularly on criterion B, yeah?
Yeah, those actually, the two that I sent you are the only exercises that I have of criterion B.
Okay, no problem. So I shall send you more work, which you should get in the course of today. But for now, definitely we have come to the end of our session. And what I'll do is, like I say, let's just stop share there. Okay, great stuff. So yeah, I'll send over all the board work, so you can obviously review the work, and you shall also get a video, and then you shall also get some extra practice questions. And I shall see you
Yeah,
on Sunday.
thank you.
How did you
Thank you so
find
much.
that?
It helped a lot. I kind of realized, well, I knew that I had gaps, but I didn't know I had so many. But that helps a lot. Thank you.
You're most welcome. I'm glad you found it helpful, and I shall see you on Sunday.
Thank you.
See you now. Bye now. Thank you. Bye.